Hi everyone, my name is Aksa Anna Shajan. I am an MSc Cybersecurity student of National College of Ireland. I'm here to present my research project. My topic is intrusion detection in IoT devices using Zero Bias DNN. With the introduction of IoT devices, many of the smart services which were previously impossible was made possible. We know that IoT devices are smart devices with inbuilt sensors and data processing capabilities when connected to internet. There is a huge increase in the number of IoT devices, ranging from 15 million devices in 2015, and it is expected to be at a range of 80 million devices by 2025. And there is one main weakness for IoT device. It has only one privilege level. Once the attacker gets access to the privilege level, gets access to the IoT device, it's very easy to perform attacks. Security becomes a concern due to its high demand and its weaknesses, so an effective intrusion detection system is needed. We are using Zero Bias DNN with MQTT-IoT-IDS 2020 dataset for our model. How effective can be the Zero Bias DNN for intrusion detection using the MQTT-IoT-IDS 2020 dataset? The traditional methods of intrusion detections were based on rule-based IDS. They used some keywords or commands for comparison, but this method seems to be ineffective. So, modern methods of machine learning have produced better results, among which DNN proves to be the best. So, we are using Zero Bias DNN method. This method was used in 2020 for proper identification of IoT devices, and it proved to have high accuracy. IoT devices uses MQTT protocol for communication. So we have got a dataset MQTT-IoT-IDS 2020 with it is the latest dataset which is completely based on IoT devices. So using the latest dataset with a new robust method could produce a satisfactory result. Observation after literature review. Having a thorough study about IoT devices, machine learning techniques, and datasets, we have identified the following. Deep neural networks are more efficient and commonly used technique for intrusion detection. None of the research papers have used MQTT IoT-IDS, and most of the papers used a dataset which contains general attack patterns in the network layer. We are fully concentrating on the IoT devices. Using zero bias layer in DNN makes the system more robust. These are the observations. Research methodology. The figure illustrates research methodology. We have 5 steps. First is the pre-processing of the dataset. First step is cleaning. Like all the empty rows will be removed. The data with attack patterns will be labeled as 1 and the other will be labeled as 0. We will create 2 files, one for testing and one for training. Random forest classifier is the algorithm we used in our model. RFE is a feature, recursive feature elimination. It's a feature in random forest classifier. This feature is used for eliminating the features. And next step is creation of Zero Bias DNN. It contains convolutional layer, flattened layer, and dense layer. The first and the last layer has got an bias initializer as 0. And then the next step is training the model with a cleaned file, and the final is the testing. Final step is the testing. The output will be either the data entered is an attack or it's a normal condition. Design specification. We first select the MQTT IoT dataset. Then we create 2 files, clean the test file and clean the train file. Then the next step is Zero Bias DNN creation. We train our system with a cleaned train file. The feature elimination is done using the RFE. During that, and the model will be created. For the testing part, when we input the data will be combined with original. We in which we have used to train the system and produce a result. The result will be either normal or the attack. This is the evaluation matrix. We are using confusion matrix. The first one is this is the true positive. Here the positive is normal and the negative is intrusion. So it's true positive, it's false positive. This is true negative and this is false negative. So we have 93% of normals were detected as normal itself and 0.91% of intrusions were detected as intrusion itself. So it's a very good rate. These are the equations for finding accuracy, recall, precision, F1 and F1 score. So we have accuracy of 92% and recall as 91, precision as 93 and F1 score is 92. These are some of the research papers previously used. These are the data sets used. Like even if some of the papers like 93.91 and 95%, these have high accuracy. Even though they have high accuracy, these data sets are very old data sets. So we have used the latest data set. These all papers concentrated on intrusion detection in IoT devices, but the dataset they used were very old. They trained the system with a dataset which contains all the general attack patterns in the network. So it includes both IoT, it includes IoT as well as many other attack patterns also. So therefore we can conclude that our dataset is the most appropriate one, and a 92% accuracy with the most appropriate dataset is a good and satisfactory result. Smart cities accounted for 28.6% of the world market in 2019, followed by industrial purpose at 26.4%. There is very much increase in IoT devices each day. Deep neural network provides best results in intrusion detections. So we have developed a zero bias DNN for intrusion detection using the latest data on dataset MQTT-IoT. That our model was trained and produced an output with an accuracy of 92%. This method seems to be a better option for identifying intrusions. As a part of future work, the model can be trained with multiple datasets to produce greater results. Thank you. Now we can see the demonstration of the implementation part. So we have imported pandas, numpy, sklearn and io. These all libraries were imported. These are all the features that were present in the dataset. First step is we read all the datasets here. All the datasets were read, and the rows with empty rows with empty values were dropped. So a cleaning is done for all the datasets over here. Then we concatenate and create one big file for that. Then we split the file to two parts, one for training and one for testing. Then we use a recursive feature elimination for we import this feature using 13 features are selected in our system. And after the pre-processing step, Next step is creating the model. So this is the DNN architecture. So convolutional layer. For the convolutional layer, we have initialized zero bias with zero bias initializer with the zeros. And here also for the second dense layer, one of the dense layer, we have given zero. We have assigned zeros to the bias initializer. We have convolutional layer, flattened layer, and dense layers for our DNN architecture. The next part is testing. For the testing part, next part is the training part. These are all the steps included for the training part. This is the file we have created for testing, and this is the file we have created for the training. And for the testing part, we have to use confusion metrics to show the accuracy. The data will be earlier. The data we enter from the test file will be combined with the file data on the train file, and the result will be produced. Smart AC technique used for data. To avoid a data balance, we have used the smart oversampling technique. And now we can see the implementation part. This is our main screen. This is our login page. So we log in as admin. Here we have option. Here we can enter the string and we will get the result here. So for this, if we take data from the test file, like the one is labeled as the attack one. So now we are selecting the attack one. Giving the attack one as input. It checks the status and gets a result as intrusion detected. So these were the 13 features that were used. And again, now we can check for the normal condition. If we select for the normal condition, this is the normal one. Giving the input, the network is in normal condition. So there is no, this is the features of normal traffic, and the previous one was the features of attack pattern. So this is our implementation part. This is a output. That's all. So being produced. So with a 92% of accuracy on the latest dataset, I feel like it has provided a satisfactory result. Thank you.